Hello everyone, my name is Huzaifa Ansari and along with my teammates Chinmay Acharya, Manas Bhamra, Parth Bhanushali and Shruti Agarwal, we'll be presenting a project titled as Knowledge Graph Approach to Cancer Registry Data. This project addresses the challenges of managing vast cancer registry datasets such as patient demographics, treatment details, which traditional databases struggle due to rigid schemas. As we all know, cancer is one of the biggest health issues today, generating massive data volumes from patient records, socionomy data. Traditional databases lack the flexibility to handle this evolving data efficiently. Our solution, based on knowledge graphs, aim to improve the management, organization, and analysis of cancer data by allowing dynamic and flexible data handling. A knowledge graph is a flexible way to organize data as entities and relationships, unlike traditional databases. In our context, a node represents data points like a patient or a treatment, while edges represent relationships. This structure enables easy integration of new data and facilitates linking structured and unstructured data for complex analysis, such as across multiple hospitals. Now, there are several challenges faced in cancer, such as traditional SQL databases struggle with the schema modification required to accommodate involving data structures. Complex queries essential for comprehensive data analysis are hindered by rigid schemas designs. As for benefits, there are multiple benefits as well, such as facilitates seamless linkage with external data sources, enhancing depth breadth of the cancer data analysis. Efficient query execution allows for complex analysis, providing insights into multiple patient characteristics, treatment efficacy, and survival rates. The proposed framework in this is a user-friendly information services and formats facilitating easy access and analysis of the cancer-related information. The framework aims to address the challenges of cancer data organization while promoting accessibility and usability for researchers and clinicians. The layered approach in this is a processing layer that cleans, prepares for the incorporation of the knowledge graph, ensuring the data quality and consistency. The knowledge graph layer serves as a central repository, organizing the data into classes and instances for efficient querying through Spark. Now here we present you a high-level overview of the Cancer Scientific Digital Library Framework, which comprises of five things: data, processing, knowledge graph, service, and users. Multiple users such as researchers, cancer register, health provider, and etc. Services such as treatment sequence analysis, hypothesis generation, and testing. Now knowledge graph can be developed on many bases, such as age, gender, type of cancer, and processing also involves many steps, such as cleaning and generating the graph. Data can be taken from geographical data, web data, and other things as well. Now, these are some of the outputs generated by our code. So let's dive into the code to understand it. As you can see, the code, which comprises of mainly four things: the data processing, which is the data is cleaned by removing unnecessary columns, and the diagnosis is converted to binary. Visualization: a scatter plot is created to show differences between the benign and the malignant tumors based on the perimeter mean and the concavity mean. SVM model is also trained to classify tumors, achieving a 90% accuracy. Evaluation is done by building a confusion matrix to visualize the model's prediction and performance. As here you can see, the scatter plot and the confusion matrix is generated. For this part, it is a code which creates knowledge graph to visualize relationship between cancer patients and the diagnostic attributes. We sample 20 patients focusing on their key features such as radius mean and area mean, smoothness mean, concavity mean. Each patient is represented as a node and is connected to the diagnosis, benign and malignant and characteristics. The graph uses colors to distinguish the diagnosis: green for benign and red for malignant, and characteristics and blue. Here you can see that the patients as larger nodes and attributes as smaller nodes, helping us understand their relationship. As for the third part of the code, it is a knowledge graph in a circular layout to illustrate the relationship between cancer patients and the diagnostic attributes in a shell layout. Larger node represents patients while smaller node represent the characteristics like radius mean and area mean. Nodes are red color coded, light green benign malignant, and salmon for malignant, and sky blue for characteristics. Labels and arrows clarify connections between the patients and the diagnosis and the attributes. Now for the fourth part of the code, we start by loading a lung cancer data from the CSV into the data frame for easy manipulation. After cleaning the column and checking the data structure, we visualize the distribution of the lung cancer cases and gender differences. We convert the categorical values such as gender and cancer status into numbers for correction analysis. And finally, we display a heat map of the correlation matrix to help us understand how different factors affect the lung cancer. As per for the last part of the code, we create a graph to visualize the relationship between a sample lung cancer dataset. We select randomly 25 rows from the dataset, adding nodes for each patient, their gender, age, and key attributes like smoking status, chest pain. Each node connects to their gender and age, as well as the nodes to the key attributes. We then draw using a spring layout, allowing us to see the connections between the patients and the important health factors clearly. And we have taken two data sets Here we have taken two datasets such as cancer data and lung cancer data to display and implement the code. Now let's go back to the PPT to discuss some more points. Scope. For the scope, in the future, this approach could integrate real-time patient data, expand to global datasets, and incorporate AI for predictive modeling and making cancer research even more impactful. In the last part, Knowledge Graph offers a promising solution for improving the organization and analysis of cancer registry data, providing a more dynamic and efficient way to manage complex datasets. Thank you for your attention. It's been a privilege to share this analysis with